1C wants us to add complex numbers. All you have to do for complex numbers is add the like terms, so the values of the constants would go together and the variables with the i's would go together. So 4 plus 6 is going to give you 10. 9i plus a negative 2i is going to be 7i. Remember, complex numbers are always written in the format of the real number first, followed by the imaginary. 1D is subtracting complex numbers. It works just like adding, except you have to be careful. Notice the second number is being subtracted. So what you have to do is make sure that you distribute this negative sign to both of the values. So what you're going to have is the 9 minus I. A negative times 7 is negative 7. A negative times a positive 3i is negative 3i. Now just combine your like terms. So the 9 minus 7, because it owns a sign in front of it, 9 minus 7 is 2. And the negative 1i minus a 3i is going to get us a negative 4i. And that's our answer. The second problem is going to work the same way. Again, don't forget to distribute this negative sign to both. When you do that, what you're going to get is the 10 minus 3i, and then it's a negative 27. Be careful, a negative times a negative 5i becomes a positive 5i. Add your like terms. 10 minus 27 is going to give you negative 17. Negative 3i plus a 5i is going to give you a plus 2i. And that's your final answer. 2b wants us to simplify imaginary numbers. What you need to remember from this is that I squared equals negative 1. So whenever you see an I squared, you must replace it with a value of negative 1. So let's look at this first. This is negative 7 times I squared. Now be careful, this squared is just with the I. So what I'm going to do is just keep the negative 7 there, but I'm going to replace I squared with negative 1. Then you just simplify. This is multiplication. There's no plus sign here. It's negative 7 times negative 1, which gets you positive 7. Now this next one is similar, except be careful. It says negative 2i all squared. It means this entire thing happens twice. So I'm going to repeat this value 2 times. Gives you negative 2i times negative 2i. When you multiply the like terms, negative 2 times a negative 2 is going to get you a positive 4. I times I becomes I squared. Again, I squared is negative 1, so this gets replaced. So it's 4 times a negative 1, which simplifies to the answer of negative 4. This next one, I need to do I times the square root of 6 2 times. So I'm just going to repeat that as I square root of 6 times the I square root of 6. When you bring I times I together, that becomes I squared. Now remember, radicals can be squished together, so a square root of 6 times square root of 6 becomes the square root of 36. Now as you simplify, the square root of 36 is actually the number 6. Again, I squared is negative 1. So negative 1 times 6 becomes negative 6 as the final answer. 2c wants us to multiply complex numbers. This works just like multiplying any two binomials together, so you have to do the distribution. So you're going to distribute this way, except you're going to have to remember again that I squared equals negative 1. Whenever you have an I squared, you're going to replace it with negative 1. So start the simplification process. 1 times 2 is 2. Positive 1 times a positive 7i is plus 7i. A negative I times a positive 2 is negative 2i. And a negative I times a positive 7i is a minus 7i squared. Now I have two like terms that can be combined together, so plus 7i minus 2i will give us the 5i. So let's write 2 plus 5i minus 7. Be careful, I squared is negative 1. So when I simplify, this is now 2 plus 5i. This is a negative 7 times a negative 1 becomes positive 7. Now I'm not done. Remember, complex numbers is one real and one imaginary. I have to combine the two real numbers together. So 2 plus 7 is going to be 9. So the answer here is 9 plus 5i. The next one works the same way, so let's get the distribution set up and rewrite the problem. 6 times 3 is going to be 18. 6 times a negative 2i is negative 12i. 8i times a positive 3 is plus 24i. And a positive 8i times a negative 2i is going to be negative 16i squared. Again, we have two like terms, a negative 12 and a plus 24i. So negative 12i plus 24i is going to be positive 12i. So we have 18 plus 12i. Then it's minus 16. Again, I squared is negative 1, so we make it negative 1. Therefore, we have 18 plus 12i. Negative 16 times negative 1 is plus 16. We're going to combine these two like terms, which are the real numbers, and we're going to get 34 plus 12i as our final answer. 3a is simplify more advanced imaginary numbers. All you need to do in this is pull out as many I squareds as possible. So we're going to pull out as many I squareds and replace each one with a negative 1. So let's just start with I to the 11th. So I to the 11th can be represented as 1i squared. That's 2 of the i's. If I do another one, that's 4 i's. 6, 8, and 10. Don't forget I need an extra one to make the 11th. Now another way I could have written this is notice that there are 1, 2, 3, 4, 5 I squareds. So I could have said I squared to the 5th power with the remainder of the other little I out there. Now I'm just going to replace every I squared with the number negative 1. So when I do that, there's one of them, 2, 3, 4, 5, and then the remaining I there. When you multiply all these negative 1's together, these first two become a positive 1. If I take positive 1 times this negative, they now become negative 1. Take the negative times another negative, these 4 become positive. Then the last positive times a negative means all 5 of these become negative 1. So really what I'm doing is it's negative 1 times I. The answer here is negative I. Now I could have done that back over here. What I would have done is just put negative 1 in for I squared to the 5th power times I. Negative 1 to the 5th power is negative 1 times I would give me a negative I. Now if you do that for I to the 8th power, what you can write for this one is you can realize that it's I squared times I squared times I squared is 6. One more will give you the 8. Another way to write it is I squared to the 4th power. Let's replace the I squareds with negative 1. I'm just going to do negative 1 here to the 4th. If you do negative 1 times negative 1 times negative 1 times negative 1, it will become the number 1, and that's the final answer. 3b wants you to check if a complex number is a solution. There's two ways to do that. I'm going to show you one way first, what you would do. Here's the equation, x squared equals 196. They want to know if 14i works. What you can do is actually substitute 14i in for x and see if it equals 196. So if I do that, it'd be 14i squared, and I want to see if it equals 196. 14i squared just means 14i times 14i. When you simplify that, you will get 196 I squared. Don't forget though, I squared means negative 1, so this would be 196 times negative 1, which equals negative 196. Clearly we can see that does not equal a positive 196, so is this a solution? Your answer would be no. Now a second way you could do it, let's look at this one. They want to know if you have x squared minus 4 equals negative 6. Is the answer I times the square root of 2? I'm just going to take this equation and solve it for x. To get x by itself, let's first add 4 to both sides. If I add 4 to both sides, I'm going to get x squared equals negative 2. To get the x by itself, take the square root. That's going to give us x equals, careful that it's actually plus or minus the square root of negative 2. Now remember, we don't have square roots of negatives. The square root of this negative actually comes out. When that comes out, it becomes an I, and then we leave it as a positive square root of 2 on the inside. And this does have two answers, plus or minus. So is one of the answers I times the square root of 2? Yes, it is. It's right there. So for this one, I would say yes, it is a solution. Now you could have used this first method that we did here. You could have substituted this value in for x. If you do, you would have noticed this side would equal negative 6. So that would also prove it works. Now this third one here, again, we can try to solve it using algebra or substitute. I'm going to show you the substitution on this one. If I put this into here, what it's going to look like is this. 1 plus I all squared plus 2I. The question is, does it equal 0? So what I'm going to do is simplify this. Be careful, 1 plus I must be repeated twice. So what I do is 1 plus I times 1 plus I. Once I simplify that, I'll add the 2I to it. Let's do the multiplication here. That'll give us 1 plus 1I plus another 1I plus I squared. And then I have the remaining again plus 2I. We'll see what that equals. I'm going to combine these two like terms together. So that's going to give us 1 plus the 2I. But then don't forget I squared is negative 1. So I'm going to change this to a minus 1. And then there's a plus 2I right there. Now what happens is I have 1 minus 1 is 0. And then I have a plus 2I plus another 2I, which is going to give me 4I. So this would say 4I. However, be careful. They're saying this should equal 0. Clearly, when you look at this, 4I does not equal 0. This is not true. So no, this is not a solution. 4a wants us to find a complex conjugate. All you have to do is, for a complex conjugate, means take the imaginary portion and change its sign. So the complex number, negative 3 plus 7i, its complex conjugate is negative 3 minus 7i. For this one, 63 minus 14i, its complex conjugate, the real part stays the same, but it changes to positive 14i. 4b wants us to divide complex numbers. Now, complex numbers are not considered simplified if there's an imaginary value on the bottom. You have to get rid of that. The only way to get rid of the imaginary number on the bottom is to multiply this by its complex conjugate. So you always take the bottom number and change it. So 5 plus I, its conjugate is 5 minus I. Now if I multiply the bottom of a fraction by 5 minus I have to be consistent and do the top. So what I did basically is just created two multiplication problems. I need to multiply these two numbers and these two numbers. Let's start with the distribution for the top. 2 times 5 is 10. 2 times negative I is negative 2I. Negative 3i times a positive 5 is negative 15i. A negative 3i times a negative I is a positive 3i squared. Now on the bottom, what we're going to do is the same distribution. 5 times 5 is going to get us 25. 5 times negative I is negative 5i. I times 5 is plus 5i. A positive I times a negative I is negative I squared. Let's simplify this top half first. I'm going to combine these two like terms to make negative 17i. So we're going to have 10 minus 17i. And then it's plus 3. Change the I squared to negative 1. Let's just simplify this top half one more time. This is 3 times negative 1, or negative 3. 10 plus negative 3 is 7. So this becomes 7 minus 17i. Now on the bottom, let's go back here. Negative 5i plus 5i is 0. This becomes 25 minus, change I squared to negative 1. So 25 minus a negative 1. This really is 25. These becomes plus. So the answer on the bottom is 26. Now be careful. Complex numbers need to be written as the real component and then the imaginary. So I'm going to break this up into two pieces. Our final answer here is 7 over 26 minus 17 over 26i, and that's the answer. Let's do one more example of this complex number. Again, it's not simplified because there's an imaginary on the bottom. So to get rid of that, I'm going to multiply 10 minus 2i by its complex conjugate. Its conjugate is 10 plus 2i. So I'm going to do 10 plus 2i on the bottom, and therefore I have to do it on the top. I'm going to come on in and do the distribution to the top like I did, and the distribution to the bottom. When you do that, here's what you're going to get. This will be the top, and this will be your bottom. Let's simplify the top, bring together these two like terms, and then change I squared to negative 1. So that's going to be 20 minus 6i minus a 2 times a negative 1. On the bottom, we're going to bring these two like terms together, which becomes 0. Change I squared to negative 1. That's going to give us 100, and then minus a 4 times a negative 1. When we combine this, this is a negative 2 times a negative 1 becomes positive 2. So positive 2 plus 20 is going to be 22. So we have 22 minus 6i. The bottom here, negative 4, negative 1 becomes positive 4. 100 plus 4 is 104. Now I can break up my fraction into its two pieces. When we do that, we're going to get 22 over 104 minus 6 over 104i. Now technically you should try to simplify this as much as you can, see if there's any values you can pull out. There is a common factor between these two. I can actually take, divide this by 2 and divide this by 2. If I do, 22 divided by 2 is going to be 11. 104 divided by 22 is going to be 52. Similar here, I can pull out up 2. So if you do that, divide it by 2. 6 divided by 2 is going to be your 3. So it's going to be minus 3 over 52i. This is the simplified answer in complex number format with real followed by imaginary.